Hi everybody, we're Team 12 and we designed a ski jumper. So the basis for our project was we wanted to model a Olympic ski jumper, and initial designs we wanted a weeble wobble effect, so we wanted the toy to stay vertical once it landed after. So that was kind of our basis for this project. Go ahead. So things we had to design were the arms, legs, feet, and base, the base shell, the ramp platform, the ramp base, the support, the clip, and the head and torso. Parts we bought were the wire that we used to connect the torso to the legs and base and to the arms. We used a launcher arm, which is a metal rod, and surgical tubing as our launching mechanism. And we had silly putty and lead for the weight to acquire the weeble wobble effect, and then bearing balls for the sliding motion. This is our head and torso. We have a large cavity in the middle because, like most teams, we faced volume issues. And these are our arms. The arms, we used variable section sweeps to get the shape with long sections drawn and spheres as the shoulders. These are our legs, and we modeled the legs and the feet on the skis and the base as one part. And as you can see, there's an outer shell which we use to encase the bearing balls. And here you can see how they fit in. The next one is the view of the shell. Oh. And then go to the slide with the. And this is our figure as a whole.
Alright, so then the next piece we had to make was the ramp. Yeah, so our goal here was to be able to slingshot him towards the ramp and be able to launch him into the air. So we made this out of a couple pieces. This is the base. You're going to have to hold the base when you launch him. Go on to the next one. This is the actual ramp. We went over a couple ideas of the design of the ramp. We decided a straight platform would give us the best launch angle. Really, that was just kind of a guess. We only had one chance to design this, so we kind of had to have a lot of initial thought towards how we're going to make this. This is the ladder. This holds up the ramp, and as you can see, we can adjust the height of the ramp by moving the support ladder. We have different notches where it can stay. And then this is the support. We bought this one. We bought a piece of steel for this so we can have it really strong to kind of withstand the force from the elastic when we pull back the slingshot. And again, this is just a clip. It's part of what's going to hold the ladder up, and it's going to be able to adjust the height. This is going to be attached to the base with some rubber band to hold it there nice and tight. And then this is all together. Again, you can see that it's able to adjust the height of it to get good launch. So this is kind of halfway before he's going to hit the ramp. We didn't model the elastic in Pro E, but our goal is to be able to launch him towards the ramp, have him fly through the air, land, and regardless of which way he lands, to be able to right himself and keep rolling with those ball bearings. Yeah, go ahead. So we'll show a quick video of how this is going to look modeled in Pro E. And he keeps on going. So just some final thoughts. Our design, our whole geometry, we thought was very good. We wouldn't have to change much. But for final production, we'd like a better material choice. We had some limitations with the SLA plastic and everything, and really a lighter weight material would be beneficial because it would give us a better weeble wobble effect, and also A lighter toy and maybe a smaller one would have less of a force on the ground, so you wouldn't have to really worry about damaging your floors. In addition to this, we probably couldn't use lead weights if we're going to be marketing this towards children. That never really ends up good. We might have some problems with that. And yeah, some different joints we could kind of change that. Some ball and socket might be good instead of just attaching it with wire like we did in this model. Are there any questions? All right. Thank you very much.